Hi, Algebra 1. What's up? Okay, we have, to this point, learned how to graph inequalities. We have learned how to write algebraic inequalities. We have learned how to solve algebraic equalities, remembering that when we multiply or divide by a negative, we have to flip the sign. Let's turn our attention now to solving multi-step inequalities. And for this, we're going to use pretty much all of the rules that we've used thus far. We're just going to have to do more than one per solution. So with inequalities, it's very important to simplify both sides of the equation. What just happened there? Simplify both sides of the equation before solving. And then solve just using the properties of inequality that we've learned thus far. So let's do that. Let's jump right in, shall we? Let's call this example 1. That seems logical. We're going to simplify both sides. We can't really do anything with that mess, right? We don't have like terms over there, but we do have like terms over here. So let's simplify the right side of the inequality. We have 3x minus 4 still on this side, still greater than whatever's on the right side, which we know is 5 because we've combined 7 and negative 2. Now we add 4 to both sides of the inequality. We get 3x is greater than 9. Divide by 3 on both sides, we get x is greater than 3. And we're going to check. We're always going to check. It's a good idea to do with everything, but it is crucial when you're doing inequalities, because if you accidentally forget to flip the sign, or if you've made a mistake, you're going to catch it. So let's pick a point that is greater, and we're not going to graph it. Let's pick a point that's greater than 3. How about 4? Let's substitute 4 in for the original inequality. We get 3 times 4 minus 4. It better be greater than negative 2 plus 7. We get 12 minus 4 over here. Negative 2 plus 7 still over there. This is 8. And that's greater than 5. So we feel pretty good about ourselves. We are pretty sure we did that right. All right, let's call this example number 2. How about? Sounds good. Now here, we can't combine like terms, right? We can't simplify either side of the inequality because we don't have like terms. But we can collect our x on one side of the inequality. So let's do that. We have x plus 9 is greater than x plus 4. We're going to subtract x from both sides. And we're going to get 9 is greater than 4. Well, that's always true, isn't it? What kind of inequality is this? What do you think? From what you know about equations, doesn't that kind of look like an identity? Yeah, it turns out we can have identities and inequalities too. That's pretty cool, right? I don't know why I'm making random. And finally, what about this guy? Example 3. We're going to, again, we can't simplify either side of this inequality, but we can collect our variables. We're going to subtract x from both sides, and we get 8 is less than or equal to 3. Uh-oh. Is that ever true? Like, in what universe is 8 less than 3? In what universe is 8 equal to 3? Not in any universe that has been discovered. So this is, can you guess? Can you guess what's coming? No, solution. Right? This is never true. And just like that, you know how to solve multi-step inequalities. We will do some practice.